In section 4.3 now we're going to get into the right triangle trigonometry. So this is getting away from the unit circle definition we used in the last section. Again, I'm only using the unit circle definition on the quadrantal angle. So if an angle is a quadrantal, I will do things that way. If an angle is not a quadrantal, I'll be doing it this way. So the definitions say, let theta be an acute angle of a right triangle. Okay, so here I have a right triangle, and I've chosen, so there's my right angle indicated by the box, 90 degrees. And I've just chosen this angle to be my acute angle. I could have chosen that one. So there's my theta. All right, so let me indicate the notation here. So when you have a right triangle, of course, the longest side, the side opposite the 90 degrees, is the hypotenuse. Okay, I'll just write HYP. The side, the leg, right, these are the two legs of the right triangle. The leg opposite the theta, we call the opposite side of theta. I'll just write OPP. And the leg that's adjacent, that's next to the theta, we call the adjacent side. Okay. Now the hypotenuse is also adjacent to the theta, but that's the hypotenuse. Okay, so the hypotenuse is the side opposite the right angle. The angle you've chosen, the side opposite that, is called opposite, and the side next to theta that's not the hypotenuse we call the adjacent side. Okay, so with that notation in mind, we can define the 6 trig functions of theta. So sine is the opposite side over the hypotenuse. So opposite over hypotenuse. Again, these are in the notes, but cosine is the adjacent side over the hypotenuse. Tangent is opposite over adjacent. Right. Now, just like in the last section, we noticed that there was a relationship between some of the trig functions. They were reciprocals of one another, and that's true here as well. Cosecant is hypotenuse over opposite, which is the reciprocal of sine. So sine and cosecant are reciprocals, right? Just take the reciprocal. Secant is a reciprocal of cosine, so that's hypotenuse over adjacent. And cotangent's a reciprocal of tangent. That's adjacent over opposite. So those reciprocal relationships still hold. They held for the unit circle definition we did of the trig functions, and it holds here too. So if you can just remember sine, cosine, tangent, and you know what's a reciprocal of what, you can list the others. Again, sine and cosine are not reciprocals of one another. It's sine and cosecant, cosine and secant, and tangent and cotangent. Okay? So don't make this harder than it is. Once you have a triangle picture, you know all 3 sides of the triangle, all a trig function is one side of the triangle divided by the other. Okay? Now remember, with unit circle we weren't doing the dividing. It was either x or y for cosine and sine, and then reciprocals. Notice though, I mentioned this in the last section too. You can get tangent from sine and cosine, right? It turns out tangent is sine theta over cosine theta. Now why is that? Because if I take sine theta, that's opposite over hypotenuse. And if I divide by cosine, which is adjacent over hypotenuse, well, how do you divide a fraction by another fraction? Right? You take the fraction you're dividing by, invert, and multiply. Right? So if I invert the hypotenuse, the adjacent over hypotenuse, I get hypotenuse over adjacent. The hypotenuse terms cancel, and you get opposite over adjacent, and notice that's the tangent. So if you take sine divided by cosine, you do get tangent. Okay? So once you know sine and cosine, right, from this you could do all 6 trig functions, right? You get sine, you get cosine. Tangent you can get from sine over cosine. Cosecant and secant are the reciprocals of sine and cosine. And then how do you get cotangent? Well, we know tangent and cotangent are reciprocals of one another. So cotangent is cosine over sine. So if you just remember one of these, the other you get from reciprocal. Okay? So again, don't make this harder than it is. Once you get 3 sides of the triangle, you can find the trig functions of all 6 trig functions of one of the angles. Now be careful. What if I had chosen this to be theta? That side would still be the hypotenuse, but this would have been the opposite side, and that would have been the adjacent. Okay, so it depends on which angle you pick as to what answers you get. Okay, let's do an example. It says find the values of the 6 trigonometric functions for theta in the triangle given below. So draw this picture where it says, in the triangle below. So draw the picture in. Okay, so I've chosen the theta down here as my acute angle. So here's my right angle. This side's 5, that side's 13. Well, to do all 6 trig functions, we need all 3 sides. So we need to figure out this side right here. I don't know, I'll just make up a variable. I'll call it Q. Okay, so we have the Pythagorean theorem, right? So the length of the leg squared plus the length of the leg squared is the length of the hypotenuse squared. So 5 squared plus Q squared is 13 squared. And we just have to solve for Q. Remember, it's length of the leg squared plus length of the leg squared is length of the hypotenuse squared. So this is 25 plus Q squared, 13 squared is 169. And if I subtract 25 from both sides, I get Q squared is 144, and Q is 12. Okay. This triangle is a common triangle that shows up all the time. So you might just remember 5, 12, 13. That's called the Pythagorean triple. So 5, 12, 13 is a common one that shows up in this book a lot. So you may just want to memorize. But be careful, right? If you have a triangle, with 5 and 13, that doesn't mean this side is 12, right? The hypotenuse has to be the largest side. So it's the 5 and the 12 on the legs and the 13 on the hypotenuse. Okay. Well, now that we have all 3 sides of the triangle, we can fill in all the values for the trig function. So here's my angle theta. Sine, by definition, is the opposite side over the hypotenuse. Opposite of theta is 5, and hypotenuse is 13. So it's 5, 13. So that's all you have to do. Cosine of an acute angle in the right triangle, it's the adjacent side over hypotenuse, right? Adjacent over hypotenuse. So that's 12 over 13. Pause the video and see if you can do the other 4 on your own, and then I'll do it and we'll see if we get the same thing. Okay, so for tangent of theta, tangent is opposite over adjacent, so that's 5 over 12. And remember, you can get the other 3 trig functions from the 3 we just did here. Cosecant is a reciprocal of sine, so that's 13/5. Secant is reciprocal of cosine, so that's 13/12. Tangents, cotangents are reciprocal of tangents, so that's 12 over 5. So hopefully you were able to get those answers. Okay, so it's just knowing the definitions. Okay, and again, you have to know your definitions. You can't spend half an hour singing a song to help you remember the definitions. When you take calculus and the teacher says what sine of theta, you can't go on scratch paper write them all down to help you remember, right? You just need to know the sine is opposite over hypotenuse, cosine's adjacent over hypotenuse. Okay, you just have to know them off the top of your head. Okay, now I want to talk about special triangles. So there's 2 special triangles. Let me do the easier one first. So hopefully you agree, I can make a right triangle, an isosceles right triangle, where the 2 sides here have the same length. All right? So you can make a right triangle where the two legs have the same length. So suppose I call those lengths x and x. So I call it x because on both because I'm assuming they have the same length. Well, I mean, you should know that if you're in a triangle, the biggest angle's opposite the biggest side, the smallest angle's opposite the smallest side. That's why 90 is the largest angle. These 2 angles are acute, so the hypotenuse is the largest side. That's why. Notice here I made these 2 sides of the same length, which means these 2 angles have to be the same measurement. And the only way that can happen is if this is 45 degrees and this is 45 degrees. Remember all 3 angles in a triangle, in any triangle, sum to 180 degrees. So if that's 90 and these are the same, that's going to have to add up to, they always add up to 90, but if they're the same, they'd have to be 45. Okay, let's do Pythagorean identity to figure out how big the other side is. I'll call it Q again, why not? So x squared plus x squared is Q squared. The length of the leg squared plus length of the leg squared is length of the hypotenuse square. So this is 2x squared is q squared. Now I'm trying to solve for q. Normally when you introduce a square root, you have to take plus or minus, but we're talking about lengths here. So q is the square root of 2x squared. Okay, and again, the square root of x squared, since x is positive, that's just going to be x. So you get q is the square root of 2 times x. I'm breaking up the square root, right? The square root of 2x squared is the square root of 2 times the square root of x squared. Since x is positive, the square root of x squared is just x. Right? So this q turns out to be the square root of 2x. Okay, so the x is not under the radical here. Now what is this saying? In a 45, 45, 90 degree right triangle, right? The two legs are the same, that's what this is saying. And how does the hypotenuse relate to either one of the legs? Right? It's square root of 2 times as long. So if you know one of the legs in the 45, 40, 90 triangle, how do you get the hypotenuse? You multiply by the square root of 2. That's what this is saying. Now what if you know the hypotenuse? How do you get a leg? Right? Well, if this is square root of 2x, the leg is x, you divide by square root of 2. So it's very easy. Okay? So if you're in a 45, 45, 90 degree triangle, if you know one of the legs, the other leg's the same, and how do you get the hypotenuse? Multiply by root 2. If you know the hypotenuse, how do you get one of the legs? You divide by root 2. So if you're going smaller to bigger, you multiply by root 2. Bigger to smaller, you divide by root 2. Now, normally when I'm doing the lectures, I'm not going to write the triangle this way. Normally I'm going to write the triangle where x is 1. Okay, so I'll do it this way. I'll write a 1 and a 1, and if x is 1, the hypotenuse is square root of 2. Now, when I write this, I'm interpreting it this way. I'm not saying every one of these triangles is 1, 1, root 2. I'm saying the legs are equal, and the hypotenuse is square root of 2 times as long. Okay, so I'm going to interpret it the same way I did here with x. But these two legs are the same. The hypotenuse is square root of 2 times the leg. Okay, so that's the triangle I'm always going to write when I'm working problems. Okay, now let's do the other special triangle, which is a little more complicated. Okay, so the other special triangle is the 30, 60, 90. So here's my right angle, there's my 30 degrees, and there's my 60 degrees. Notice that by my picture, I had to put the 30 degrees here, right? Smallest side is opposite smallest angle, right? Largest side is opposite largest angle, and then the middle side is opposite the middle angle. Well, before I wanted to develop it a different way, right? But I'll leave that for the end, okay? So let me develop this a different way. Okay. Hopefully you agree, I can draw an equilateral triangle, right? Now, if I have an equilateral triangle, all three sides are the same, so all three angles are the same. If all three angles have to add up to 180 degrees, that means each one of these is 60 degrees. Okay? And I'm going to, instead of writing x on each side, I'm going to put 2x. You'll see why. I'm trying to make the numbers easy. Okay? So an equilateral triangle, all three sides I'm saying have length 2x. All right? So hopefully you agree I can do that. Right? So if it was 3, 3, if all three sides were of length 3, that means x would be 3 halves. Okay? Okay. So what I want to do now is take the perpendicular bisector and cut this triangle in half coming this way. Okay? So let me just take half. So I'm taking half the triangle here. So I'll just take the right half. Okay, let me draw. This isn't to scale, but okay. So I still have the 60 degrees here. I still have the 2x here. Okay. Notice this angle got bisected in half, so this angle here is 30 degrees. So you see I'm heading towards this. And notice that length was 2x, but I cut it in half, so that became x. Okay? So I just drew this to show you it makes sense that I can have a triangle like this, an equilateral triangle of sides of length 2x. When I cut it in half, that gives me this. Okay? So let me continue with what same idea we did before. Let me call this side Q and figure out what Q is in terms of my x's. So Now I have a right triangle. My original triangle wasn't a right triangle, it was equilateral with all angles 60. But now I did the perpendicular bisector, so I have a right triangle. I can use Pythagorean theorem on it. Q squared plus x squared is 2x whole thing squared, quantity squared. Now let's solve for q. So q squared plus x squared, well 2x times 2x is 4x squared. And if I subtract x squared from both sides, I get q squared is 3x squared. And now if you take the square root of both sides, again, we only need the positive square root. It's the square root. Q is the square root of 3x squared. But I can break that root up again, so that's root 3 times the square root of x squared. Since x is positive, the square root of x squared is x. So this side that I call q is now square root of 3x. Now how do we interpret this? Okay, it's a little more complicated than the one we did a second ago, the 45, 45, 90, because on that one, 2 of the sides were equal. None of the sides are not equal here. Okay? All right, let me write this. I'm going to draw some arrows here. Now, whenever I do anything with this triangle, I always involve the small side, the shortest side. Okay? I never try to go hypotenuse to long leg, because there's 2 numbers involved and I get confused. Right? So let me focus on the short side and the hypotenuse. Again, this is the short side because it's opposite the 30, not the way I've drawn it, it's because it's opposite the 30. So what is this telling you? If you know the short side, the short leg, how do you get the hypotenuse from that? Well, if that's x, that's 2x, so you double it. Right? So if you take the short side and double it, you get the hypotenuse. Now how do you go from the hypotenuse to the short side? You take half of it. Right? So you're either multiplying by 2 or dividing by 2. Maybe I should write it that way, right? So you multiply by 2 to go from short to short leg hypotenuse. To go hypotenuse to short leg, you divide by 2. Okay? Now what is this saying? Now I'm not going to go from here to here. There's 2 numbers involved. If you know the short side, how do you get the long leg? Right? Well, if this is x, that's root 3x. So if we go from here to here, you multiply by square root of 3 because you're getting bigger. And how do you go from the long leg to the short leg? You divide by root 3. Right? So if you can just remember the 2 is, there's the 1 and the 2. So you're either multiplying or dividing by 2. To go from short to long, you multiply. Long to short, you divide. Same thing here. To go from short to long, you multiply. Long to short, you divide. You just have to remember you're multiplying and dividing by 2 when you use the hypotenuse, and root 3 when you're using the long leg. Now again, just like on the other one, I don't do it with the x's. I let x be 1, just like I did on the 45, 45, 90. So opposite the 30 is 1. Well, what's the hypotenuse? When x is 1, the hypotenuse is 2. And when x is 1 here, the long leg is root 3. So that's the picture I'm going to draw whenever I do the 30, 60, 90 triangle instead of the x. But what am I saying here? The hypotenuse is double the short side. The long leg is root 3 times the short side. Root 3 times 1 is root 3. That's what I was doing here. 2 times 1 is 2. So to go from short leg to hypotenuse, you double. Hypotenuse to the short leg, you divide by 2. From short side to the long leg, you multiply by root 3. To go from here to here, you divide by root 3. Okay, so I was trying to explain where all this is coming from, but that's the triangle, the special triangle I'm going to draw. And remember, it's not always 1 on the left and root 3 on the bottom. No, no, no. The 1 is opposite the 30, okay? Because it's the short side. Okay, so we've developed the special triangle. Let's do an example here. Okay, so there's a picture here. So you want to draw the picture. So the right angle is there. This is a 60-degree angle over here. The hypotenuse is 18. X is the length of the leg at the bottom, and Y is the length of the leg on the right. Okay. So it says find the exact values of X and Y in the figure below. Now, this is a right triangle. This angle is 60 degrees, which means the angle up here is 30 degrees. Remember, the 2 acute angles in a right triangle have to add up to 90 degrees. Because all 3 have to add up to 180, and we've already used 90 here. Okay, now this is one of our special triangle problems. It's the 30, 60, 90 triangle, okay? The two special triangles are 45, 45, 90 degrees and 30, 60, 90 degrees. So this is our special triangle. And notice it says find the exact values. That means you do not punch in the calculator around. You don't even need to use a calculator on this. Okay, so notice we have the hypotenuse, 18. Again, I always involve the short side in every single one of these. I never go from hypotenuse to long leg. I always use the short side. What's the relationship between the hypotenuse and the short side? Again, that's the short side because it's opposite the 30 degrees, which is the smallest angle. Well, remember the hypotenuse is double the short side. So that tells me x is 9. There's no work to do here, right? I'm just using the special triangle properties. Okay, the hypotenuse is double the short side in the 30, 60, 90 triangle. Now that I have the short side, how do you go from the short side to the long leg? Well, remember the long leg is root 3 times the short side. So y is 9 root 3. There's no work to show here. Okay, it's just do you understand the numbers that we're using, right? So to go from short leg to hypotenuse, you double. Hypotenuse to short side, you divide by 2. To go from short leg to long leg, you multiply by root 3. Long leg to short leg, you divide by root 3. That's all I'm using here. Okay? So that was that one. I gave a lot of room in the notes for a very short problem. Okay, so the next example says, find the exact values of all 6 trig functions for 45 degrees. Okay, so if I draw the 45, 45, 90 triangle, right? So if I draw the 45, 45, 90 triangle, again, this isn't necessarily a scale. Now, what are the numbers? If you can just remember the 3 numbers, you can figure out where they go. Remember on the 45, 45, 90, it's 1, 1 square root of 2. 1, 1 square root of 2. You know the legs are the same, so that's 1 and 1, and that's square root of 2. Okay, so if you can just remember the 3 numbers, root 2 is the largest of the 3. It has to be on the hypotenuse. The other ones have to be 1. So now I've turned this into, like this problem we did over here with the 5, 12, 13. I have all 3 numbers on the triangle. This is the acute angle I've chosen, and it says find all 6 of them. So I need sine of 45 degrees, cosine of 45 degrees, tangent of 45 degrees. Always label your work. Cosecant of 45 degrees, secant of 45 degrees, and cotangent of 45 degrees. So all 6 of your basic trig functions. But again, once you have sine, cosine, tangent, you can take your reciprocals to get the other 3. Okay? Now remember, what was the definition of sine? I'm using 45 degrees as my acute angle. I could have done it 45 up here as well. You'll get the same answers. Remember, sine was opposite over hypotenuse. So opposite over hypotenuse is 1 over root 2. Now, I'm not going to rationalize. I think that's kind of archaic. But again, answers in the back of the book and electronically are probably going to rationalize. So remember how to rationalize. You multiply by root 2 over root 2, and you get root 2 over 2. Again, I'm perfectly happy with that, but that's an answer they would give in the back of the book. Okay, now what about cosine? Cosine of 45 is adjacent over hypotenuse, so that's also 1 over root 2. Again, I'm not going to rationalize, but the back of the book would expect you to. Now, what's the definition of tangent? Tangent was opposite over adjacent. Opposite over adjacent, that's 1 over 1, which is 1. Okay, and then you could just use the definition. Remember, cosecant is hypotenuse over opposite, or it's the reciprocal of the sine, right? So either way, you get square root of 2. It's square root of 2 over 1. And then secant's the reciprocal of cosine, so that's also square root of 2. Or you could say hypotenuse over adjacent, square root of 2 over 1. And then cotangent is a reciprocal of tangent, 1 over 1 is 1. Or you could say cotangent's adjacent over opposite, 1 over 1 is 1. Okay? So once you have the triangle picture, it's just like this one. You just have to remember your definitions. It's plugging and chugging. Okay, the next example says do the same thing. Do the same thing for pi over 6. Now I've done everything in degrees, but just be aware that you could do the same thing in radians. Now what's pi over 6? Remember, pi over 6 radians was 30 degrees. So it falls in our special triangle category. So I'm just going to put pi over 6 here. If it helps you, you can put the 30 degrees. But you should label your answers with the answer that's given. So I want sine pi over 6, cosine pi over 6, tangent pi over 6, cosecant pi over 6, secant pi over 6, and cotan pi over 6. Since they gave me pi over 6, you should label it that way in your answer. You should be consistent. Plus, again, in calc, everything is used with radians, so you need to get used to that. Okay, so this is my 30 degrees. This is my 30, 60, 90 triangle, right? This is pi over 3, which is 60 degrees, right? This is the angle I'm using. I'm taking the trig function of. Now, what numbers go on this triangle? Remember, in the 30, 60, 90 triangle, the three numbers are 1, 2, square root of 3. So 45, 45, 90 is 1, 1, square root of 2. The 30, 60, 90 triangle is 1, 2, square root of 3. Now, again, if you have problems, remember where numbers go. Of these three numbers, which one's the largest? Right, square root of 3 is 1.7 something, I think, right? So 2 is the largest value, so it has to go on the hypotenuse, right? Now, of the remaining two numbers, which one's the smaller of the two? 1 is smaller than root 3. That's the short side, and it's opposite the smallest angle, which is pi over 6, right? That was 30 degrees, so the 1 is here, and the root 3 is here. If you can just remember the three numbers, you can figure out where they go. Largest number on the hypotenuse, smallest number opposite the smallest angle. Okay, and now we have our triangle picture, and we just plug and chug like we always do. Why don't you pause the video and go ahead and fill those in, and then I will do it, and we'll see if we get the same thing. Okay, so sine is opposite over hypotenuse, that's 1/2. Cosine is adjacent over hypotenuse, that's square root of 3 over 2. Tangents, opposite over adjacent, that's 1 over root 3. Cosecant's reciprocal of sine. Secant's a reciprocal of cosine. Cotan's a reciprocal of tangent. And again, I mean, the book is going to want you to rationalize those two answers. Okay, so that's that one. Okay, the next problem, it's more calculator problems. Okay, so we can do these. There's only one little difference here between the ones we did in the last section, I believe. A couple differences maybe. So the first one says sine of 22.8 degrees. I'm going to write them all down. Then cosine cubed of 6 pi over 17. The next one is secant of 9 pi over 11, tan of 90 degrees, cotangent of pi over 2, and then cosecant of 41 degrees, 15 minutes, 32 seconds. So we did problems similar to this in the last section. Now notice some of these angles are in degree measure. That one's degrees, minutes, seconds. And some of these are in radian measure, right? I know it's radian, not because of the pi, because there's no degree sign. So I don't think I'm going to do these in order. Let's do all the degree ones first, so then we don't have to change the mode in the calculator, and then we can do the radian ones. Okay, so before you do anything, you need to check your mode. I'm still in degree mode from the previous section. Right, so I'm going to do the sine problem, the tan problem, and the cosecant problem. Right, so sine of 22.8 degrees, you just type it in as it's written, but you don't need the degree sign if you're in degree mode, which I am. Sine of 22.8 degrees is, does it say how many places to round to? 3 decimal places. 0.388, because it's 0.3875, so I rounded up. 0.388. Okay, now what about tangent of 90? Well, we have a tangent button, so tan of 90 equals, and I got error domain. Now be careful, on certain calculators they'll tell you what the error is. If it says error syntax, that just means you dropped a parentheses or you hit the plus sign twice or something like that. So a syntax error is something you type something in funny and you need to fix it. But a domain error says you're asking the calculator to compute something it can't compute. And so the way you interpret that here is this is undefined. And I think we saw that, we did an example in the last section where we found, I think, tangent of 90. That was 1, we got 1 divided by 0. Remember, that's a quadrantal angle, right? Remember, 90 degrees is here, on the unit circle, that's the point 0, 1. Remember, tangent was y over x. 1 over 0 is undefined. So we did that before. We did in the last section. But this is the calculator verifying that for you. Okay? And then the last one that has degrees in it is cosecant of this 41 degrees, 15 minutes, 32 seconds. Now remember, there's no cosecant button. How do you need to type this in the calculator? Cosecant and sine are reciprocals. This is 1 over the sine of 41 degrees, 15 minutes, 32 seconds. Okay? And remember, the way I'm going to type that in, it's 41 plus 15 over 60 plus 32 over 3600. So sine, 1 over sine of 41 plus 15 over 60 plus 32 over 3600. And don't forget to close up that parentheses. I'm getting 1.516 to 3 places. Again, make sure you get the same thing. So I did 1 over sine of 41 plus 15 over 60 plus 32 over 3600 in parentheses. Okay, so those are the 3 with the degrees. Now let's go back and do the radians. Now the first thing we have to discuss is this notation, right? Cosine cubed of 6 pi over 7. That means this. It's cosine of 6 pi over 17, whole thing cubed. That's what that notation means. That's why I did this, to explain the notation. See, if you put the cube here, if you wrote cosine, say, of x cubed, are you cubing the x and then taking the cosine, or are you taking the cosine and then cubing? This actually means that. You cube the x first. So just to prevent us from having to write brackets or parentheses around the whole thing every single time, they have this special notation, right? So be aware this means this. And you can't type it in the calculator the way it's written. It'll give you a syntax error. It doesn't like that. So you have to put this whole thing in parentheses and then cube. Now the first thing we need to do is change your mode to radians. 6 pi over 17 is in radians. So I'm going to have to change my mode to radians. So every problem where you're taking sine of something or tangent of something or cosecant of something, before you type anything in, you need to check your mode. And sometimes I'm guilty of not doing that and I get the wrong answer. So I am now in radian mode, so you need parentheses, or parentheses, cosine, give me another parentheses, 6 pi over 17, parentheses for the angle, parentheses for the whole thing, and then cubed. Remember, to get the cube, you have to do the caret button, which is above the one above the division sign, the caret like that. And when I hit enter, I get to 3 places 0.089. It's 0.0885, so you have to take that 3rd place and round it up. Right? So I typed it in parentheses, cosine parentheses, 6 pi over 17, parentheses, caret, cube. Okay, so that's what I got. Okay, so I'm still in radian mode, so I can do this one now. There's no secant button, but remember, secant's a reciprocal of cosine, so this is 1 over cosine of 9 pi over 11. So that's how you have to type that one in. 1 divided by cosine 9 pi over 11. Don't forget to close out your parentheses there. And I get negative 1.189 to 3 places. Okay, negative 1.189. And then our last one here, it says cotan of pi over 2. Now this one's a little tricky, right? If we actually write that as 1 over, remember, we don't have a cotan button, that's 1 over tan of pi over 2, right? Tangent, cotangent are reciprocals of one another. But if you do 1 divided by tan of pi over 2, you get a domain error. So you'd be inclined here to write undefined, but that's not the correct answer. Okay? That's why I'm doing this one, because this one's tricky. Okay? So let's think about this for a second. Okay? Remember, pi over 2 is 90 degrees. Okay? So pi over 2 is a quadrantal angle. Let's not, it says to use the calculator to do it, but we need to go back to the previous section. Pi over 2 radians is 90 degrees, so there's pi over 2 radians. It's a quadrantal angle. You have to be careful using the calculator on certain quadrantal angles. Now see, here we got undefined, but I explained why it was undefined. I'm going to do the same thing here. So on the unit circle, that's the point 0, 1. Now what was cotan? Cotan was x over y. Notice cotan of pi over 2 is 0 over 1, which is 0. So the correct answer here is 0. If you're not careful and you just believe the calculator, it's going to give you undefined, which is not the correct answer. The reason is because think about what we typed in. I typed in 1 over tan of pi over 2. But tan of pi over 2 is undefined. So I basically typed in the calculator 1 over undefined. Well, 1 over undefined is undefined, and that's what the calculator told me. The problem is, right, the cotangent of pi over 2 is actually 0 over 1, which is 0. Okay? See, what we were doing was 1 over 0, which doesn't make any sense. Okay? So be careful about when you're using the calculator with the quadrantal angles. If you get an undefined, you may want to think a little further ahead, right? This one we got undefined, but it was undefined because that was 1 over 0. Okay? But here, cotan is 0 over 1. We were telling the calculator 1 over 0, which is undefined. Okay, so be careful with the calculator on quadrantals. I think for quadrantals, it's safer just to do the pictures we did in the last section. Okay, so let's do an example here about where this comes into play. How do we, now that we know how to do the trig function of acute angles, we can use it to solve some problems. So the next example says, there's a figure in the book. A biologist wants to know the width W of a river to properly set instruments for an experiment. Okay. From point A, so this is on the bank here. So here's the bank. So here's point A right here. From point A, the biologist walks downstream 100 feet. Okay, so they walk downstream 100 feet. So this is 100 feet. And sights to point C. Okay, so C is on the other side of the river here, right, like directly across from A. So there's point C. So from here, they walk down the river 100 feet, and they set aside. What they mean is, if you've ever seen the surveyors out on the road, so they have a tripod and a little machine, and they're looking through, and there's somebody far away holding a pole with a flag on it. So that's what they're doing. They're setting the sight. And so they do that this way, and they find that the angle here is 54 degrees. 54 degrees. From this sighting, it's determined that the angle theta here is 54 degrees. How wide is the river? Okay, so this is the W, right? That's W, that's what they're looking for. And this is a sort of real life sort of thing, right? How do you measure across a body of water, right? You can't just, take one of those poles with the wheel on it and just walk across and measure the width. So this is what they do. Notice they measured a width along the land, which you can do. They used, some surveying instruments to figure out this angle right here. Right? And then because A is directly across from C, this is a right angle. Okay? So we're trying to find this side W. Now here's the procedure in finding elements in a right triangle. Okay? Right? You choose one of the acute angles. Don't choose the right angle. Choose one of the acute angles and two of the sides. Notice that's three things, right? One acute angle and two sides. Of those three things, you need two of them. So either an angle and a side or two sides. Okay? So if you know two of those three things, you can find the one that's missing. Now I usually just choose what's given. I'm going to choose that acute angle and those two sides. Okay? So there's three things involved. Two of them I know, so I can find the third element. Okay? That's the procedure. Choose an acute angle and two of the sides. From those three things, you have to know two of them to find the third, and we do. Okay? So you do that first. Choose the acute angle and the two sides. Then ask yourself, which trig function relates that angle to those two sides? You don't pick the trig function first. Pick the angle and the two sides, then ask yourself what trig function relates. And notice here's the angle, that's the opposite side, and that's the adjacent side. Now what trig functions have an opposite and an adjacent? That's tangent and cotangent. Now you can pick either one you want, but since I'm going to punch in the calculator and get a decimal, you might as well pick sine, cosine, or tangent. Okay, because then you don't have to do a reciprocal. So I usually pick sine, cosine, or tangent. So here I'm going to pick tangent. Okay, now what's tangent of that angle? Tangent of 54 degrees is the opposite side, W, over the adjacent side, 100. Okay, so the procedure, choose one of the acute angles and two of the sides. Of those three things, you have to know two of them. then pick the trig function that relates that angle on those two sides, and then set up the relationship, right? Tan of 54, tan of that angle is opposite over hypotenuse. Now it's an algebra problem. How do we solve for W? Well, you want to get rid of the 100, so if you multiply both sides by 100, you'll have your W. Right? 100 times that is that, 100 times this, the hundreds cancel, you get W. And now you see why we did the practicing with the calculator, because we need to punch this in, and we know how to. Now what if I just type in 100 tan of 54? 100 tan of 54. I got 67.38. Which sounds like a perfectly reasonable answer. But what did I forget to do? Right? I'm still in radian mode, and this angle's in degrees. Before you just start typing in, you need to check your mode. So I need to go back to degree mode here. And I'll do it again. 100 tan of 54 is 137, if I go to two places, 0.64 feet. So the answer I got sounded perfectly reasonable, but it was going to be wrong. Don't forget to check your mode every time you type in. I was going to type in tan of an angle, so you have to check your mode. Okay, so the width of the river is 137.64 feet. Okay, let's do another example like that. It's not a physical application problem, it's just a straightforward triangle. And so on the next page here, we have to draw the picture. This is not to scale. So angle C is the right angle, angle A is up here, angle B is here. Angle B is 49.3 degrees. Right, and then the other sides are labeled little b and little c. It's standard labeling when you're doing triangles. Sorry. And the other side down here is 58. Okay, it's standard to use capital letters for angles and lowercase letters for sides, but there's a way we label. Little b is opposite capital B. Little c is opposite capital C. 58 here is lowercase a. Little a is across from capital A. Right? So if they don't give you a figure, if they said, A is 20 degrees and little a is 15 and capital C is 90 degrees, right? When you put your C is there, it doesn't matter where A would be, but if I put A here with 20 degrees, little a is across from that, okay? So little a and capital A are across from each other. Little b and little capital B are across from each other, okay? So C doesn't have to be the hypotenuse, little c, but it's standard typically to call capital C the hypotenuse, but it doesn't have to be. But see, notice, if they tell you this, you can draw the picture. They don't have to give the picture to you. So just keep that in mind. Okay, so the instructions say solve the right triangle. When they say solve the triangle, that means find everything, all the angles, all the sides. Notice in the previous example, they only asked for the width of the river, so we only had to find one thing. Okay, here they want us to find everything. Well, we already know C, we already know B, but we need capital A. I usually try to find the easiest thing first, right? So how do you get A out of this, right? I'm labeling what I'm doing, right? Remember, the two acute angles in a right triangle have to sum to 90 degrees. So to get A, it's 90 degrees minus B, 49.3. So A turns out to be 40.7 degrees. Right. So if you want, you can put that in the picture now if you need it. Okay. Okay, so so we have all the angles. Now we need the sides. Okay, now what's the procedure? Oh, could we use Pythagorean theorem here to find one of the missing sides? Well, no, that's a problem, right? The Pythagorean theorem has three variables in it, all three sides. To find one of them, you need the other two. I only have one side, so you can't use Pythagorean theorem here. What do? We do the procedure I just mentioned in the previous example. Choose one of the acute angles and two of the sides of those three things. You have to know two of them. Now, I could use this angle if I wanted to. I have it now, but I like to use what's given. So I'm going to choose the angle that was given, the side that I know, and I'll just choose B. Okay? So I've chosen one of the acute angles and two of the sides. Of those three things, I know two of them. That's the first step. Then you ask yourself what trig function relates to that angle to those two sides. Well, it's opposite and adjacent, and that involves tangent. It's exactly like the last problem on this part. So set up your relationship. Tangent of your angle. Be careful, don't take tangent of a sine. You take a trig function of an angle. Tan of the angle is the opposite b over the adjacent 58. Tangent of the angle is opposite over adjacent. And now it's just a matter of algebra again. So to solve for b, I need to multiply both sides by 58. So b is 58 tangent of 49.3 degrees. And we punch it in and we'll have our answer. Again, check your mode. I'm in degree mode, so I'm good. 58 tangent 49.3. 58 tangent 49.3. B is 67.43. It's two places. It didn't say what to round to. And I don't know the units. I didn't put any units on the side. So if this were 58 feet, this would be feet, for example. Now, if I wanted to, I could find side C with Pythagorean theorem. Okay, I could do 58 squared plus 67.43 squared to C squared. So you could use Pythagorean theorem here, but just for more practice, okay, let's find C without Pythagorean theorem. So I'm pretending I hadn't found B, okay? So suppose I hadn't found B, we could have found C first, so why don't we do it this way? So I'm going to choose the acute angle and these two sides. Again, if I wanted to use B as one of my sides to find C, I could, but I've rounded here, so I like to use what was given. That's just me, right? So I'm choosing that acute angle that was given, the side that was given, and the side I'm looking for. So I chose an acute angle and two sides. Of the three things, I know two of them, so I can find the third. Now, what trig function relates this angle to these two sides? This is the adjacent side, and that's the hypotenuse. Now, what trig function has adjacent and hypotenuse in it? That's cosine and secant, but I'm going to use cosine, okay, because there's a cosine button on the calculator. So cosine of 49.3 degrees is the adjacent side, 58, over the hypotenuse, little c. Right? Cosine of the angle is the adjacent over the hypotenuse. Okay, now this one, we're going to have to do an extra step here. Notice in this previous part, the variable was in the numerator, so it was easy to solve for. Here, the variable's in the denominator, so we have to do an extra step. Let me write that step up here. Well, let me just do it. Let's get C out of the denominator. So let's multiply both sides by C. So I get C times cosine of 49.3 degrees. And I'm going to multiply this side by C. The C's cancel, and I get 58. So the first goal is get the variable out of the denominator. Here it was in the numerator, so it wasn't an issue. Here it's in the denominator. So multiply both sides by C. So C cosine 49.3. Here the C's cancel, you get 58. Now how do you get C by itself? You divide by the cosine. So C is 58 divided by the cosine of 49.3 degrees. Okay, so if we type that in, we will have our value for C. I'm still in degree mode. Notice I'm checking it every single time. 58 over divided by cosine of 49.3, and that's about 88.94 feet or inches or whatever the length of 58, whatever units on the 58. So I think I've solved the triangle, right? I have all three angles, and I have, there's little a, there's little b, and I have all three sides. Now what's nice about doing it this way, it's not that hard, but you can check your work. It's nice to check it a completely different way. See if a squared plus b squared is c squared, right? 58 squared, that's a squared, plus b squared, 67.43 squared. I'm getting about 7910.8. Now that should be the same as c squared. 88.94 squared is 7910.32. So it's off a little bit because of the rounding. But that makes me think I did everything correctly, right? I did each of these this way, and the Pythagorean theorem holds. So it's always nice to check it a completely different way. Okay, so we solved the triangle, the right triangle. We found everything. But just remember the procedure. Choose an acute angle and two of the sides. Then choose the trig function that relates the three of them. Then set up the relationship. Now we have three more identities here. These are called the Pythagorean identities. And think about what Pythagorean theorem said. One's a side squared plus a side squared is hypotenuse squared. Something squared plus something squared is something squared. And these have the same format. That's why they're Pythagorean identities. So the first one is sine squared theta plus cosine squared theta is 1. The next one is 1 plus tangent squared theta is secant squared theta. And if you can remember this one, the second one, the third one's the same. Just put co. Say the word co in front of those. 1 plus cotan squared theta is cosecant squared theta. Okay, so if you can remember the first two, you can get the third one by just putting co here. Okay, so 1 plus tangent squared theta, secant squared theta, 1 plus cotangent squared theta is cosecant squared theta. So those are your three Pythagorean identities. You need to know these. They show up in calculus all the time. You need to know them. Now notice the angle that goes here is the same as the angle that goes, those two angles have to be the same, those two angles have to be the same, those two angles have to be the same. So what's an identity? If you plug any angle into here, it will make it true. Same thing here, when they're defined, right? We saw the tangent of 90 degrees was undefined. So if you plug 90 into here, it's not going to make any sense, okay? So just be aware, when you get an answer on both sides, they're going to be equal to each other. So if one of these is undefined, it's not going to make any sense. So the example says, use the calculator to verify the three Pythagorean identities hold for theta's 23 degrees. I just picked 23 out of the blue. Right? So in the first one, if I do sine squared of 23 degrees plus cosine squared of 23 degrees, according to this, you should get 1. Okay, so we're going to type it in the calculator, but remember what this notation means. That's sine of 23 degrees, whole thing squared. That's what that notation means. Plus cosine of 23 degrees, whole thing squared. Okay, so if we type that, we know what we're going to get. The answer is supposed to be 1, but let's check it. So check my mode, degrees. So parentheses, sine of 23 squared plus cosine, oops, I forgot my parentheses, cosine 23, parentheses, squared, and lo and behold, I got 1, which is what the identity says we're supposed to get. Okay, let's do the second one. This one is 1 plus tangent of 23 degrees, whole thing squared. Now, I'm not going to get 1 there. It's supposed to be secant, right? So then we're going to have to do secant of 23 squared. So 1 plus tangent of 23 squared should be secant of 23 squared. So let's punch this in and see what we get. So 1 plus parentheses tangent 23 parentheses squared. So I get about 1.18017. It's actually 8. I'll round here to 1.1802. Now, how do we type in secant 23 squared? That's 1 over cosine of 23 squared. Remember, secant, cosine are reciprocals. So 1 divided by cosine 23, I didn't do my square. 1 divided by parentheses cosine 23 parentheses squared. And lo and behold, 1.1802. So they are equal. And we knew they were going to be. And then the last one, same thing. We need 1 plus cotangent 23 degrees squared. And that should be cosecant of 23 degrees, whole thing squared. Now, how are we supposed to type this mess in? Remember, we don't have a cotan button. So this is 1 plus cotangent is 1 over tangent. So that's how you have to type that in. And likewise here, right, cosecant is 1 over sine, right? So this is 1 over sine of 23 degrees squared. So if we type those in, they're supposed to be the same according to this. 1 plus cotan squared 23 degrees should be cosecant squared 23 degrees. So 1 plus 1 divided by parentheses tangent 23 parentheses squared. I'm getting 6.5500. And I should get the same thing here. So 1 divided by sine of 23. I forgot the first parentheses. 1 divided by parentheses sine of 23 parentheses squared. And I got the same thing, which I know I would. See, if I hadn't put the parentheses, it would square the 23 and then take the sine, and I would have gotten the wrong answer. Let me verify. 1 over sine of 23 squared. Yeah, yeah. Okay. Okay, so we only did it for 23, but these are true for any angle. Again, anything you put here and here, if you put 10 degrees or 100 degrees or radians, even if you did these in radians, they work. Okay, but again, sometimes some of these here and these are always defined. Sine and cosine of an angle always gives you an answer, so this is always true. But if you plug a certain angle in here, you may get an undefined. Okay, so when both sides do give you numbers, they will be equal to one another. Now, just to explain, I mean, we checked it with one value, but I want to explain why at least this first one is true. You could do the same procedure on the other two. So I'll just verify for the first two. Okay, so let me start with sine squared plus cosine squared. I want to convince you have to get a 1 out of this. Okay, so let me write it this way. That means sine of theta, whole thing squared, cosine theta, whole thing squared. Well, let's go back to our definitions, okay? So remember, if I put in a right triangle, if I put theta here, that's the opposite, that's the hypotenuse, and that's the adjacent side. Right? Well, what was the definition of sine theta? Right? Sine was opposite over hypotenuse, so we have the opposite over the hypotenuse. I could call those letters to make this easier, but this is all right. I could have called it like, A, B, and C. Right? Now, what's the definition of cosine? Cosine of theta is adjacent over hypotenuse, so that's adjacent over hypotenuse. Okay, so if we square, if you have a fraction, right, if you have a over b, whole thing squared, that's a squared over b squared. So this is the opposite side squared over the hypotenuse squared, and this is the adjacent side squared over the hypotenuse squared. So notice we have two fractions with a common denominator already, so we can add those two together. So here we have the opposite squared plus the adjacent squared. So that, I know that looks messy, but it's easy to simplify. Remember, we're in a right triangle here. What's the opposite side squared plus the adjacent side squared? We'll use Pythagorean theorem. The opposite side squared plus the adjacent side squared is the hypotenuse squared. That's Pythagorean theorem. So the numerator turns out to be the hypotenuse squared. We have hypotenuse squared in the denominator. It's something divided by itself, and lo and behold, you get the 1, which is what it said it was going to be. So you could play the same game with the other two Pythagorean identities, like the 1 plus tangent square, 1 plus tangent square, use my picture to get tangent, do some algebra, and you can get the secant square. Okay, so that's all the information we need here on the right triangle trig.